Today we're going to start chapter 8. Today we're going to be looking at multiplying and dividing rational expressions. This first example on your note sheet is one where we are going to look at multiplying or dividing one of these. So it says the goodie shop sells candy and nuts by the pound. One item is a mixture made with 8 pounds of peanuts and 5 pounds of cashews. Therefore, 8 over the combination of 8 plus 5 pounds of the total nuts would be 8 out of 13 would show the ratio of peanuts to the total nuts. If the store manager adds an additional X pounds of peanuts to the mixture, write a new ratio, show what proportion of the mixture is peanuts. All right, well, if we have 8 out of the total 13 right now being peanuts to total nuts, if we add 8 pounds or X pounds of peanuts to the mixture, that's what we'd have for peanuts, but we also need to add it to the total. So our new mixture now is 8 plus X over 13 plus X. And that's an example of a rational expression. So today we'll look at other types of rational expressions. We're also going to look at how do you multiply, divide them. All right, let's talk about rational expressions then. A rational expression is a ratio of two polynomial expressions. Remember, ratio from last year is comparing two things, and it's always going to be in a fraction. So we're going to be looking at fractions here. There's an example over on the right of a rational expression. You can see on the top, we have a polynomial. On the bottom, we also have a polynomial. So that's the type of equations we're going to be looking at. We're going to do different things with them. We're going to look at simplifying them, and also with some of these, look at seeing if can we factor any of them. All right, multiplying. What do we do when we multiply? When we multiply rational expressions, you want to do two things. Anytime you're multiplying fractions, you want to multiply across the numerators. You also want to multiply across the denominators. So in this example over here, that's what we'd want to do to simplify. Multiply across the top, multiply across the bottom. If we multiply across the top, we'd have 5x times the quantity x minus 2. On the bottom, if we multiply, we got the quantity x plus 1 times x minus 1. Now we could go through and simplify that more by doing some distributing. On top, we could distribute 5x. We'd end up with 5x squared minus 10x. On bottom, we could go through and distribute there. We'd have to use that FOIL process, first outside, inside, last. And if you notice, that's a difference of 2 squares. The middle terms would end up canceling. We'd get x squared minus 1 if we multiplied and went through that. All right, dividing rational expressions. When we multiply fractions, we talked about multiply across the top, multiply across the bottom, multiply numerators, denominators. When we divide, we don't really talk about dividing fractions much. What we do instead is multiply by the reciprocal. We want to multiply by the reciprocal of the divisor. Whatever on the bottom, we want to multiply by that. So in this next example, it's the same one we just did, except it's dividing. Instead of dividing, what we're going to say is this one is 5x over x plus 1 times, now we take the reciprocal of the second one. Reciprocal basically means flip the fraction around, so x minus 1 appears on top and x minus 2 appears on bottom. And then we'd go through and do the multiplying similar to how we did on the last one to simplify it. Okay. So what are those steps we want to be doing then? We want to try to, as we go through now and simplify, factor everything we can. Simplify. Another word for simplify is canceling out or trying to eliminate things that you can see on top and bottom, numerator and denominator. Perform the operation, whether it be multiplying, dividing, add, subtract, and then factor, simplify again if you can. All right, so let's look at an example. Number 1, we want to multiply, you can see the multiply symbol, these two rational expressions. All right, so what we said, when we multiply across the top, multiply across the bottom. Let's multiply across the numerator first. 4 times 15 gives us 60. A and b squared are different variables, so we're just going to write it as ab squared. Now we're going to do the same thing with the denominator. 5 times 16 gives us 80. And then we have b times a cubed. I'm going to write it in alphabetical order just so it'll make it easier as we do our canceling later. Okay, now we multiplied, now we try to simplify. So we want to look for, can we cancel anything out? Well, let's start with the numbers. Is there any numbers that go into 60 and 80? Well, for sure you can see probably 10 does. I think there's even a number bigger, 20. 20 would go into both of those. So now you want to see how many times does 20 go into each number? Well, 20 would go into 60 3 times. 20 would go into 80 4 times. So that's going to be part of our answer. Now you want to keep going with the variables. How many variables can you cancel out? Well, over here you see we have 1a on top. We got 3 a's on bottom. How many a's can we cancel out then if we got 1 on top, 3 on bottom? One of them. So we'd be left with a squared in the denominator. Same thing with the b's. We got 2 on top, 1 on bottom. How many can we cancel out? One of them. So there'd be 1b left on top. And that's our answer. So multiply, simplify, and you got the answer. All right. On the second problem, now you can see the stop sign. I put that there for a reason. So because this one, not multiplying, this is a dividing one. So before you go through and try to start simplifying, we have to change that to multiplication. Anytime it's a division problem, change it to multiplication by multiplying by the reciprocal. So the first step in this one, before we do anything, let's rewrite it. We got 4x squared y over 15 a cubed b cubed times, we're going to switch this one around here, 5ab cubed over the quantity 2x y squared. Okay, now we can do it just like the last problem. Multiply the numerators, multiply the denominators. So if we multiply across the top, 5 times 4 is 20. And you can see none of our variables match up. So just write them all out. And I'm going to put them in alphabetical order again, just to make it easier later, so when we're canceling, we have everything the same. On the bottom, if we do the same thing, 15 times 2, 30. We got a cubed, b cubed, x, y squared. Now we go through and try to figure out what's going to cancel out here. What's going to cancel? Well, what numbers go into 20 and 30? 10 does. 10 goes into 20 2 times, goes into 30 3 times. Now let's cancel our a's. 1 on top, 3 on bottom. We can cancel 1. There'd be 2 left on bottom. Looking at our b's, b3 on the top, b the third, b cubed on bottom, those just straight cancel out. There's not going to be any b's left in our answer. X's, we can see one of them cancel. There'd be 1 left on top. Y's, 1 would cancel as well. 1 would be left on bottom. There's our solution. That's our solution. All right. Let's move to the next one. Number 3, we're going to do this one a little bit different. Now, you can multiply across the top, multiply across the bottom, similar to like we did on the first ones. This one, I'm going to show you a little bit different way of doing it. If you like this way, you can certainly do it this way as well. You don't have to necessarily multiply before you simplify. You could, if you want to, start simplifying right away. For example, when we multiply, we know anything on the bottom is going to stay on the bottom, anything on the top is going to stay at the top. So we could cancel out if we see some cancellation possible. For example, this 5 on the bottom, 15 on the top. We know 5 goes into 15. So we could say 5 is going to go into 5 one time. 5 is going to go into 15 3 times. So we can simplify even before we multiply. Similar with 8 and 12. 4 is the number that goes into both. 4 goes into 8 twice, goes into 12 3 times. And we could keep going. Now we see there's a 3 on bottom and a 3 on top. 3 goes into 3 once. 3 goes into 3 once as well. So all our numbers cancel out. There'd only be a 2 left on top. And we could combine together our variables maybe now and do another round of simplifying here. So let's combine our variables. We have m squared. We have 2 n's on top and another r. On bottom, we have m to the third n squared r squared. Simplifying the variables now, after multiplying across, we would have 2 on top. There'd be 1 m left on bottom after canceling. Our n's all cancel out, and there'd be 1 r left. So the answer would be 2 over mr. Okay. Going on to the next problem. This is, again is a division one. You can see the stop sign there. What do we got to remember to do? Change it from dividing to multiplying. And we do that by doing the reciprocal. So before you start going on this one, make sure you change from dividing to multiplying. So take the reciprocal, multiply, and keep going. I'm going to let you try number 4. I want you to try number 4. Also try 5 and 6. See what you get on those. Right now, though, let's turn to the back. We're also going to look at some different types of rational expressions where we have some adding and subtracting. Before we get into those, let's kind of review some factoring. Factoring, remember, is where you try to take a term and factor out any greatest common factor, or maybe factored into 2 binomials. That's what we're going to have to do on number 7. This is a quadratic. We want to figure out on this one, in order to factor, what's going to multiply to the last number, negative 12, and add to this middle term, negative 4. So if we think of numbers that multiply to negative 12, we could have 12 and 1. That doesn't work. 6 and 2. Looks like 6 and 2 might work here. 6 times 2 is 12. And I think we want negative 6 in order to add to negative 4. So factoring that out, we would have x minus 6 times the quantity x plus 2. Okay. Let's try another one here. Number 8. Again, we were trying to think of what numbers are going to multiply to 2, add to 3. Well, the only thing that adds to 2 is, or multiplies to 2, I'm sorry, is 2 times 1. So this one would factor into the quantity x plus 2 times x plus 1. All right, we have one more here. Let's look at number 9. This one, we're going to try and factor 2. A little bit different type of factoring, though. This one only has 2 terms. This would be one where we want to, instead of factoring into 2 binomials, factor out the greatest common factor. What's the greatest common factor? What's the biggest thing we can take out of both of these 2 terms? Well, looking at the number part, 4 and 12, is there a number that goes into 4 and 12? Yeah, 4 actually goes into both. So we're going to factor out a 4. Now we want to look at our variable x. How many x's do each of them have? At least 1. Both of them have at least 1. Both of them have at least 2, but not 3. Only the first term has 3 x's. The second term doesn't. So we can factor out an x squared. What's left then? In the first term, if we divide 4x cubed by 4x squared, there'd be a single x. With the next term, 12 divided by 4 would be 3. And there wouldn't be any variables left because we already have x squared there. So that would be the factoring for that one. All right, why do we talk about factoring? Well, our other examples, such as number 10, we're going to have to use this type of factoring to solve. So in number 10, what we're going to do is try to figure out what factors. So we're going to look at the top and try to see in this first part what factors out. Is there anything that factors? What multiplies the negative 8 adds to 2? So that would be x minus 2 times x plus 4. Okay. Looking at the next part, we want to do the same thing. What's going to factor in the next part? Looks like we can factor out a greatest common factor of 3. So there'd be x plus 1 left over. On bottom, we want to do the same type of factoring. What factors there? What multiplies 3 adds to 4? X plus 3 times x plus 1. And then we have this x minus 2 left over. From there, you go and factor. All right, we'll finish the rest in class.